Okay, this is just a really quick example to show how we use Newton's second law to solve really simple problems in mechanics. So the question reads as follows: if a 1 kilogram body has an acceleration of 2 meters per second squared at 20 degrees to the positive direction of the x-axis, what is the net force acting on the body? So let's see how we go about solving this. Well, first of all, let's draw a diagram which kind of shows the different forces acting here. So we have motion in this two-dimensional plane because it says it's at 20 degrees to the positive direction. Let's just mark that angle on there as alpha. And this is the acceleration that we're given in the problem. So we have that the magnitude of this acceleration is 2 meters per second squared, magnitude, and this angle here, this alpha, is 20 degrees, which if you work in radians is 0.349 radians. Okay, so in order to calculate what this force is, well, we need to resolve this into horizontal and vertical components, or x and y components. So we can do that as follows. We just have that the acceleration in I and j coordinates is going to be this 2 meters per second squared. That's the magnitude. 2.00 is the magnitude. And then in this x direction, we're going to have cosine alpha I, and in the y direction, we're going to have sine alpha. So that's j. So that's our acceleration. Nice and simple. And we can actually substitute in our value of alpha there in order to get what these numbers are. So we will get 1.88I, and we'll get 0.684j. So that's our acceleration in I and j coordinates. And the force then is just the mass times that acceleration. And it's nice and simple because here our mass is just 1 kilogram. So we get that the force is equal to this same expression, but of course the thing that makes this different, and I haven't marked this on for my acceleration, is the units. Okay, so the acceleration is in units of meters per second squared, but when I multiply that by a mass, I get kilograms meters per second squared, which we know is just newtons. So that's the resultant force acting on our particle, which is causing this acceleration.